Number 8. Number 8. Is my number 8 different from your guys' number 8? Is everything I have on the board different now? I'm confused.
Yeah.
Oh, that's incorrect. Okay, so, but all I'm saying is what I have on the board is incorrect.
It's number 10. Number 10 is on there.
Oh, okay. Oh, there we go. So my number 10 is number 8. Oh, and that's why I'm off in my numbers. Okay, well, let's go ahead and take a look at, but what is it on your paper?
It's number 8.
It is number 8. Okay, well, so we'll just keep on going with what's on the board here. So number 8 was done by Vanessa. Thank you, Vanessa. She had to do the cube root of 64, k to the 12th. And so she broke down 64 as 4 times 4 times 4. And she did the grouping method where she looked for triples. So she had a triple of 4s. Oh, and so Vanessa, you didn't show all of your Ks, but you're saying there's 12 Ks there.
I forgot to put like the 4 on.
Oh, I see what you're doing. You're doing k to the 4th 3 times. Oh yeah, now that's interesting, folks. We have not done a solution like that. Instead of writing k to the 12th and literally writing k 12 times, she wrote k to the 4th 3 times. Does that work?
Yep.
Yeah, because you add exponents when you multiply. So k to the 4th times k to the 4th times k to the 4th is k to the 12th. And that way she has a triplet of k to the 4ths. That's a very neat solution. We haven't seen one just like it. So now she had a triplet of 4s, so she brought out a 4, and a triplet of k to the 4th, so she brought out a k to the 4th. That totally works. Now, Vanessa, I like your solution. You get full credit. One more solution on this one is that after rewriting the 64 as 4 cubed, and that's k to the 12th, what's another way to solve this problem? The root index is the same as a what? How do I bring that 4 inside? Yeah, the 4 becomes the denominator. So I can bring that in and make that 4 to the 3/4. And no, sorry, that's not a 4. That's a 3. There we go. That makes more sense. So I can bring that 3 in as the denominator of those, terms. And then the root term goes away. So what you really have is 4 to the 3/3 and k to the 12/3. Does anyone like that method better? Of bringing the root index inside as a denominator. It's a good method, and so that just leaves us with 4 to the 1st times k to the 4th, which is the same solution Vanessa has. So either way you want to do it, that works. Okay, how about number 9? Was it a Pythagorean theorem? No, number 9 was this one, 80k to the 7th. Why not have? Oh, I do have that. Oh, and that is number 9. How strange. This is very strange. Okay, so number 9 then. So I just must have switched 8 and 10 somehow? All right, so who did this one? Number 9, Mick. So she's doing the square root of 80k to the 7th, q to the 8th. And watch closely what she did here. She said that 80 was the same as 2 to the 4th and 5 to the 1st. Is that what she did? Oh yeah, here she goes. She did 80, she broke it down into 2, 2, 2, 2, and 5. So, Mick, there's just one thing I want to change about what you have here, and that is that if you already slipped the root index underneath, should you keep the square root sign? Right, the square root sign goes away. Because you slipped that root index as a denominator, that's now gone, which is the benefit of doing fractional exponents, is that you get to get rid of the square root. So instead now, and Mick, I'm just going to show everybody where you got those numbers from. What she really did was she rewrote this as, instead of 80 k to the 7th, q to the 8th, she has 2 to the 4th, 5 to the 1st, k to the 6th, k to the 1st, q to the 8th. So that was actually Mick's first step, is that she rewrote this as even exponents with leftover 1 exponents. So she chose to rewrite her k's so that she had an even power of k and a 1. And she also has a 5 to the power of 1, and then every other exponent is even. Why does she want every exponent to be even as much as possible? Why do we want to make exponents even? Like, why rewrite k to the 7th as k to the 6th times k to the 1st? Mick, why'd you do it? Yeah, exactly, because we have a root index of 2, and we're going to put a 2 underneath all of those. So it'd be really ideal if, as much as possible, those exponents were even numbers, which will simplify. And so she'll just have 2 terms left over, such that it's a fraction that won't simplify. Okay, so that's where Mick got, was 2 to the 4 halves, 5 to the 1 half, 6 to the, k to the 6 halves, k to the 1 half, and q to the 8 halves. And some of them simplified, namely this one, and this one. Those simplified out. So that became the -4 k cubed and q to the 4th. Whereas these didn't simplify. So Mick, what'd you do with the 5 to the 1/2 and k to the 1/2? Yeah, so you just put it right back into the square root. So that's it. Very nice. I'll give you a full solution for that. I just wanted to make sure everybody knew what steps you took. Questions about those folks? All of these solutions are looking really good. So moving on then to number 10. So here number 10 was done by Ariana. Ariana did a Pythagorean theorem problem. And so this was the triangle she was given. Yeah, B918, where that was a leg, and a hypotenuse. So she did leg squared plus leg squared equals hypotenuse squared. Simplified her squares to get b squared plus 81 and 324. Moved the 18 over, got b squared equals 243. And then she simplified root 243 to 9 root 3. Ariana, tell us what method you used to do that.
Well, look at the number line.
Oh, you did look at the number line.
And then I divided it by half, like easier.
Uh-huh.
And then I checked if I just went like 81 was like the second that I checked.
And it worked.
3 times.
Okay, good. Yeah, so the only thing I would change here, Ariana, is that technically 243, this is root 243. Right? So she wrote down root 243 into root 81 root 3, which breaks down into 9 root 3. And that was her final answer. Yeah, really nice. That's it. The last thing I suppose you could do just to make the answer pop would be to put your answer back on the triangle. That way your audience gets to see your answer in context. You know, if you can imagine that there was an audience member who was sitting at home like, what's B? How big is that leg? At the very end of it, they would be really happy if you put the number on the leg, because then they'd say, oh, that's how long the leg is. So it's an audience thing. Okay, very nice. Thank you, Ariana. Thank you, everybody. So now we're going to move on to number 11 and 12 and 13. Of course, my PowerPoint is off, so I suppose we don't even need this screen up because you can just write up the problems yourself. So let's go to new 11, 12, 13. Lily, Jesus, and Matthew. There's a nice purple markers for it. Huh? It is my pencil. All right, come on.
I have training questions on the test.
Okay.
I do these two. And I keep getting them.
Did we finish these two?
Yeah.
Wait, we didn't do them? Oh, we didn't get that far, did we? Oh, well, we still have to do these. Oh, well, good. Thanks for reminding me. We have to do those. So let's just see what you wrote down. You had that, and then you knew that they could see a distance of 20, so you put that in. And, so that's the only difference here. If we want to solve for h, right, is that what we want?
Yep,
How
something
high? So we want to solve for h. H is being square rooted and multiplied by 1.6. So you can't subtract it off.
Oh,
You'd have to
so I
divide
have
it
to
off.
divide that.
Yep. Otherwise, you
And
didn't.
that's probably what I did down here too.
Yeah, so let's look. You
So
wanted to solve.
I figured this in first, and then I thought, well, I can't do that because I keep getting that and then
Gotcha. So once you plug, yeah, that's 6.28. So now you want to get L. L is being divided by 38, square rooted, and multiplied by 6.28. So you divide out the 6.28, square the radical,
Okay.
then multiply out the 38. Yeah, thanks for reminding me. Oh my gosh, we still need to do those problems. Silly me. Yeah. Yes. Why? Yeah, because that's not simplifiable, neither is that. So yeah, you're done. Dig in. You're good? No more questions. All right. Well, I hope you are. But that's a matter of percentage cost, which determines not me. I was wondering if you had a question. Okay? Emily, I'm back. Good. Yeah, you ignored me last time. I said, Mr. G, get out of here.
So for these two problems, do you have to remember?
Yeah, well, I mean, you always have to remember the number. You're going to be crushed with it. rest of your life. You know, remembering the number. But yeah, I think it's helpful. Now, I mean, you don't have to do 243. You could always break it down like using a factor tree. So you could say 243 is really 81 times 3, which is really 9 times 9, which is really 3 times 3 times 3 times 3. So what I really have is 3 to the 7. Right? 1, 2, 3, 4, 5. No, 5. So that's what we really have to do with that. So we want to know what's the square root of 3. It's 243 is 3%. Well, so the same thing as what we were saying, I could break that into the square root of 3 to the 4th times 3 to the 1st. Right? So then I can call this square root and slip that number into the denominator of both of those. So then what I really have, I realize I'm working on it.
That's okay, I understand.
So then I have 3 to the 4 halves and 3 to the 1 half. So now working down, 4 halves is just 2, so 3 squared is 9. And then 3 to the 1 half is really square root. So you can still get 9 root 3 however you want to do it. You know, if you're asking me, do you have to do it this way? Well, no, you can do it this way. Or you can do the grouping method. You know, 3 to the 5th. That gives you 1, 2, 3, 4, 5. You could have 2 pairs of 3s and then 1 left in. So that means you'd have 2 pairs of 3s on the outside and then 1 on the inside. So that's still 9 root 3 there as well. So it's 3 different ways that you can solve that problem. So what's your question? Do you have to do it that way? No, do you have to remember?
I like this.
But that's fine if you want to do the grouping. I won't take it personally either way. Edward. Well, let's see. You started. Yeah, actually, the solution is looking really good. In fact, I mean, you've done 90% of the problem. It's different. Yeah, well, let's look at the key instruction. The key instruction says rationalize the denominator. So far, you haven't rationalized anything. What you've done is look at the numerator and denominator, get the numerator, simplify the denominator, and you got this. So what is rationalizing the denominator? It means you're not allowed to leave a square root in the denominator. Rationalize means turn a square root into a whole number. And the method was, what do you do? Multiply top and bottom by what? So now you're going to multiply top and bottom by root 7, right? Multiply top and bottom by root 7. Why are you allowed to multiply top and bottom by root 7? What's root 7? Well, that's true, but why are you allowed to multiply top and bottom by root 7? Why am I allowed to just write down multiply by root 7 on root 7? Well, that's true. I am doing it from the top and bottom. Both sides one to the left and right. Top and bottom. But what is root 7 by root 7? Exactly. You're allowed to do that because you're really multiplying by 1. Multiplying by 1 root 7. There you go. Perfect. There you go, you did it. Now the key behind what you just did was you rationalized this problem. Okay, at the very beginning, the root is in the bottom, and that's the one. There's technically I'm glad you're okay. That's wonderful. I was wondering if you had math questions. Okay. Come on. Who's that guy? Did you guys meet before this class? You not? So you do each other. You guys beside. Don't. Yeah. No, seriously, guys. You guys know each other. Sorry. Yeah. I was figuring this out. Okay. You what? You make. Oh, that's you do that to him. Yeah. What's that move called? Egg. Yeah. Oh no, I haven't seen that. That's the cartoon. I've never seen that. All right. Okay, so what's your question? Oh no. Is this? I'm glad. All right, then. No, not right now. Okay. Sorry. Okay. So what does it say? Yeah. So alpha little yeah. So standard alpha. Yes, she is. That is starting with right, correct. Standard alpha states that if you want to solve for a variable, you have to look at the variable and say what is happening. So what's happening? It's getting divided by k. It's being square rooted, and then. Right. Okay, so now let's bring all that over to a nice sentence. Okay, you would say, what's currently happening? That was being divided by k square rooted. You say, what's happening? Perfect. Okay, so that's the story of that. So to solve the problem, you go backwards and reverse, doing the opposite of those facts that you say. So listen closely to what that's what you say. L is being divided by k, square rooted, and multiplied by 2 times. What's the opposite of that? Yeah. So you just go ahead and divide both sides by 2 times. Now what's the benefit of dividing by 2 times? I mean, why is this? Because if you say the whole story in the text, it's the opposite of the last thing you said. Why would I divide by 2 times? That's really our goal. Our goal is cancellation. Algebra is a destructive force. So I'm always trying to destroy it. Okay, so now move on down to the here with your 5 Excellent. So this whole process that we're going to do is that over and over again. We're really just getting it out and getting rid of everything that's around. Okay. So now, again, what's happening? Did you say the last thing you said? Just the opposite square root? Well, yeah, multiplying by itself is square. Square. Here, let's just write this in. Plus and minus are opposites. Multiply divided are opposites. Square and root are opposites. Those are all opposite operations. So when we say L is being divided by K is square rooted, it equals the square root. So we wrap it in parentheses and we put over 2 outside. Now we're squaring this. And what's the purpose of squaring outside? It can't. Now notice, you see my cancellation? See my cancellation? That's the whole goal. Hold on, let's hold on. Everything you do is something that's something. Okay, keep going. Just for example. Well, almost. You have to multiply 2 times itself. What's 2 times 2? Remember how we said multiply by 2 times? So all those times only goes 2 times. So you want to do 2 times 2. What's 2 times 2? I don't know. Yes, it is awesome. Yeah, no. You don't have to do the 3 more. That's why we have to Yes, that's right. Okay, equals L. Now we still want to solve for L, which is the same exact process. What's happening? And so we're going to multiply both sides by no, that looks pretty good. Your K is somewhat good. I would really like to because both sides of this equation are calculus. And if you're multiplying by K, that means you're multiplying numerator. And why is it that we're multiplying by K? What we don't want to do is write K, because that would be confusing. This is the top and bottom. So if you write it in top of it, make sure that it looks visually. You could even put a line over 1 to make it even more obvious. And then the same thing here. You don't have to put over 1, but I want you to write the K as the function you could put over 1. Because that makes it very obvious that the K is going to be. You can put the other 1. It's just putting up 1 that's the K. Now, right? Now, hold on a second. We've been working down. If you suddenly come over to the right, here's this one, this, and this. I'll just keep working down. Yeah, you got it. Just right next to each other, face each other. You're gonna put the whole spot.
No, the price thing.
Yeah, now, okay, now look at that. This is really good. Not only that, but this outdoor is really good. And I want you to know, hold on. There's probably a little bit inside, like every single thing. We also have cancellation here, here. In any good algebra, you're gonna see cancellation. You should look at this. So you're destroying things. And then the last thing you can work with is in the long run, you want the signs stacked right on top of each other. Because then it just looks really like super tight. Someone will be able to get yeah, that's what you did. Now you know that one? Covered up really good. No, seriously. Covered up really good. Because that would really solidify it. That's it. All right, let's see these next couple of solutions. A whole bunch of people just came up here. Who was it? 11, 12, 13? So 11 was Lily. Lily, do you have two L's or one L in your name?
Just one.
I mean, other than the fact that there's obviously two, but I mean that one. It's just one? So it's Liliette with one L. But later on, there's two T's. How can you keep track of it all? All right. So Liliette did number 11, which was another Pythagorean theorem. And she did the b squared plus 4 squared equals 6 squared. Got it all down to root 20. And then she simplified root 20 into root 4 root 5, which is 2 root 5. And then she put it all in the diagram. Thank you very much. And that looks great. So a very nice solution. Matthew did number 13, and he was multiplying two binomial expressions with a root in it. And he did FOIL. You can tell because it was lines. So he did a root times a root is a root. And a root times a whole number is just, you write it down. So root 5 times 6 is just 6 root 5. You did a whole number times a root, you just write it down. And then a whole number times a whole number, you just write it down. Folks, what else can Matthew do to this expression? Nothing. Right? There's nothing else left to do. You can't simplify root 30, you can't simplify root 5, you can't simplify root 6, and yet I claim there's one more thing Matthew could have written down. So it equals 0? Well, is it equal to 0? I was going to say the last thing you could do is just put a smiley face because you're done. Yeah. No. Is this equal to 0, folks? I mean, you could type it into your calculator. Is it equal to 0? Huh. Folks, this is a great question. Is this equal to 0? I mean, don't type it into your calculator. I'm just challenging you. Okay, you're walking down the street. I'm in cash cab. I'm like, hop in. I'll give you $100 if you can answer this question. Is this equal to 0? What's that, Jesus? You say it is? You owe me $100 because it isn't. Slam. Okay. So folks, is this equal to 0? Well, first of all, if you look at this expression, you might be like, gosh, I don't know. I mean, I'm adding, I'm subtracting. It could equal out to 0. But look back up here. If this thing is equal to 0, what does that tell you about one of these? One of them must equal 0. Well, let's look at this one. Is root 5 minus 4 equal 0? What's the only way that that could equal 0? Is if root 5 was equal to 4. And is root 5 equal to 4? Definitely not. Now what about this? Could that equal 0? Root 6 is a positive number. 6 is a positive number. Can two positives add up to 0? No. So absolutely and definitively, this thing is not equal to 0 because it's already factored in by the 0 product rule. If it were equal to 0, one of those would be 0, but it isn't, so it isn't. All right. Okay, that was a good question, though. All right, next after Matthew is Jackie. Jackie, I really like what you have right here. You didn't do that? Wait, who did number 12? Oh, Jesus. Why did I think Jackie? Oh, I was all the way down to 14. I see. Jesus, I'm really interested in your use of the word correct in quotation marks. Is that kind of like how, like, if I was checking your work, you're like, hey, how did I do it? I'm like, it's right. It's what? You're doing number 18.
No, because
Deegan is.
I told you it's wrong. It's wrong.
Oh, okay. So Jesus, you did do this one, right? And Deegan, you didn't do this one. He did this. Okay. So Jesus, why did you write correct in quotation marks? Well, good. I'm definitely laughing and smiling. I love the whole idea. Like if I was trying to impress my wife by cleaning the house, I'm like, honey, look, I cleaned the house, and she's like, nice. Like then I know I'd be in trouble. She's like, you did good work. I'm like, oh no, I thought I did. So to me, air quotes always means like tongue in cheek, not really. Is that what quotes mean? If you're like, hey, you look good today, like, would you think that's a compliment? Probably not. Yeah, okay, so when you say correct answer, I automatically think, what, is it wrong? So let's find out. So Jesus, he did 2 root 8, 6 root 72, and he went ahead and came over here and did his scratch work, which is just fine. So we did root 8 is really 2 root 2, and root 72 is really 6 root 2. And then, Jesus, are you saying that this is equal to that, or are you saying this equal sign to bring you down to the next line? Okay, down to the next line. Okay, so then he put in for root 8 the 2 root 2. For root 72, he put in 6 root 2. What's going on here, Jesus? Is this the square root of 6 and the square root of 2, or is that the square root of 6 root 2? Is that too many square roots? Is that supposed to be a parenthesis? All right, I think that's supposed to be a parenthesis. There you go. That's it. And then you multiply the whole times the whole, so 4 root 2, whole times the whole, 36. And sure enough, 4 root 2s plus 36 root 2s is 40 root 2s. Yeah, this is definitely the correct answer, Jesus. All right. What's that? Yeah, it all came out. Yeah, that must have just been a typo. We all make typos from time to time. Yeah, really nice solution, full credit. All right, so who do we have next? Oh, my alarm did just go off, so we can all take a break. That's up through Jesus, Matthew, so the next one would be Jackie. Let's go ahead and take a break. The time is 1:42, so 1:52. 1:52. Oh, okay, so we have an hour after this, right? Yeah, we have an hour. Okay, that makes sense. And we'll definitely go back and finish those last two.
I figured them out. So.
Yes.
Square root of 72 simplifies to 6 root 2. So
Oh, did he do that wrong? Wait, yeah. No, that's correct. It is 6 root 2. Somehow.
I can't figure out.
Somehow. Okay, so you'd like to know how?
Yeah.
Okay, I want to show you how.
Is it?
6 root 2?
Yeah.
Definitely. How do I know it's the right answer? That's how we know it's the right answer, because they both give the same decimal. So now the question is, how do we figure that out? So how do we figure that out?
9 is a square.
Yep, 9 squared. Mm-hmm. Super.
So that's the quick answer as well.
Kind of. Root 72 is equal to 3 root 8 is equal to 6 root 2. It's also equal to, I'm just going to go out on a limb here. So what on earth does this mean?
It means that I don't understand those.
Well, let's look over here. Here, I'm going to show you. This is going to be really fun. You're going to love it. You're going to say, whoa, I love this. So root 72 is really 2, 3, right? So let's play alternate realities. In one reality, I just circle a pair of 2s and take that out. So then I'd have a 2 outside with what's left inside? 3 times 3 is 9 times 3 is 18. Yeah. So that's one possible answer. In another reality, I take out a pair of 3s. So now I take out a pair of 3s, and now what's left inside?
2 times 2 is 8.
Okay. In another reality, I take out a pair of 2s and a pair of 3s. So 2 times 3 is 6. What's left behind? All of them are the same. Because it just depends on what you're taking out. So what's our goal? Between these, which is the better answer?
That one is also.
Yeah, it's the smallest root. It's the best answer because now this root 8, I can simplify it. Now I can take my root 8 and call that root 4 times 2, which is 3 root 4 root 2, which is 3 times 2 root 2, which gave me 6 root 2, which is what we say the better answer is. And then root 18, same thing. I can say that's root 9 root 2, which is 2 times 3 root 2, which is also 6 root 2. So if you apply the algorithm, simplify it as much as you possibly can, they all lead to 6 root 2. How's that? Now can I show it to you a different way? So you've got the square root or the square number line. Oops. Okay, and we want to simplify to the 72. So what square number goes into 72? Yeah, 36 does. So then we would call that root 36 root 2, which is the 6 root 2. What other square number goes into 72? 9. So now I call that root 9 root 8, which is 3 root 8. What other square number goes into 72? So now I have root 4 times 18, which is 2 root 18. So the problem here was that we had multiple square numbers that go into 72. But which one do we want to choose? The biggest one. Why did this problem end up having more? Because it so happens that 36 is divisible by square numbers. Not every square number is divisible by square numbers. It's very special. Look at what that said. That answered your question? I don't really follow this one right here. The word, this doesn't necessarily demonstrate how he got his answer.
Which are these?
Like, how did he get his answer? I don't know. Jesus, how did you get your answer here? Because here I see very clearly what you did. You said 8 was 4 times 2 is root 4 root 2, which is 2 root 2. But Jesus, how did you get this one? You clearly showed me here how you got 2 root 2. But over here, I don't know how you got 6 root 2.
I'm trying to figure out how he got that.
Well, it doesn't say on the board. That's the thing. It doesn't show on the board how he got it.
It's like 2 times 3 you get it?
2 times 3.
There's 3 2, right?
Right. Yeah. Okay, so you're saying that you brought out this pair of 2s and that pair of 3s? I'm asking you.
2 like, because there's 3 2s, right?
Yeah, there's 3 2s.
Yeah.
And then 2 times 3 is 6.
Yeah.
And there's 2 left.
Just a single leftover.
Right?
Jesus, I think I know what you're trying to describe. You're saying that 72 is actually 2 times 2 times 2 times 3 times 3. And so you brought out a single pair of 2s and a single pair of 3s, and that's why you're telling me 2 times 3 is 6. And so then you have 6, and what's still left in the root? 2.
Is that correct?
Yeah.
Okay.
Yeah. So Jesus, what you did here was great. This, you were showing us how you got the answer. Here, you left it to the audience's imagination and confusion. Poor Emily was confused. That was your laziness? Okay. Jesus, I like the idea of when a teacher takes off a point on a test, they can say, I was just too lazy to give you all the points. It's laziness. Does it? Oh, neat. Geez, I hope not. But that would be kind of funny. I would have given you all the points. It was just too hard. It was hard work. What, try this method? Or just not showing any work? Nah, show your work, Jesus. I know you want to. You're just messing with me.
Right on 17. You showed me how to solve it, but I did it differently.
Where? Which one?
17. So when I took the square root out by doing the twos, now when it's like this, wouldn't you combine like terms first? Because I came up with one, but yours is that.
Yeah. So there's a main reason why this is false. You didn't isolate the root. You need to send one of those roots to the right.
Okay, then.
And as soon as you send it to the right, you have an equal sign in between them,
Okay.
which changes it. It's not combining 9 minus 2 is 7. It's minusing no.
Because this is what I would do. So like.
This is correct.
That's the one Jesus showed me. And so my question is like, once you take out the square roots on this one, this would be without the square roots.
Yeah, but you can't just take away the square roots. And more than that, you're subtracting. So theoretically, the subtraction would go to both of them. So it'd be minus 2a minus 8.
Oh, okay.
So there's multiple things with what's happening right here.
Okay.
Multiple things wrong with what's happening.
Okay.
The main thing is you have to isolate the roots. So if you have a root and then minus another root and it equals 0, these two roots are together on one side of an equation. That's what I mean by isolate the root. It has to be all by itself on one side of the equation. Right now, the 0 is isolated. So what you'd have to do is add that root over to the other side. Now it's gone over here, and now you have a single root isolated and another single root isolated. Now you can square both sides, canceling the roots, and then you just have 9a minus 7 and 2a plus 8.
Okay.
Okay?
Okay, that makes
The key
sense.
is isolating the root. Did you write that down anywhere in your notes? Isolate the root?
Yeah.
I would definitely write that down.
Okay.
That was part of what we wrote down on the board. Isolate the root.
Should there be a negative 5 there? Where?
Yes, that's it. There should be. Yeah.
What happened to the girl I used to sit with?
I don't know. That's kind of loud.
Huh?
That's kind of loud.
No, I used to talk to her.
You hear it? I don't know.
I don't know. I don't know what she was.
Well, let's keep going, folks. Let's see here. That's all done. The next person to go would be Jackie and Jasmine and maybe Kai. Yeah, Jackie, Jasmine, Kai, come on up. No, it's all right. Where's my pencil? There it is. Today work my way around. Oh, oh, we'll do those at the end together. Sure. Well, So you got two roots on one side. But then the whole thing is, and that's the main idea, is that you want the root to be on one side of the equation, all that side. You can have. That's your isolation first. Oh, yeah. How's it going? Question? Okay, yeah, you got one. So, you guys want to see? Oh, goody. Have you already started before you come in today? Oh, wow, where you go?
do it.
Good. No, okay. Matthew, have you ever been to one of those match conferences in Arizona? I figure it's good enough. No. I mean, think about Jackie. That's all. I don't think you have to be a, you know, I mean, if we're gonna start charging actually.
14.
Remember taking that square, you said that?
Yeah.
So everybody's right. Two.
So what could be 2 to 7?
Any question? This one right here? Okay, so what do we want to do? We sure did. We're gonna use the same approach we did. Did we say it up here? Yeah. Okay, so yeah, do that one conversation and then I'll check. You should go to the next one. Well, interesting. Well, think about it. Brother. So let's look at this. They're saying, given the plane is going at 70,000, so let's make this is the altitude and that's the distance. Now, when you say this is the altitude and the whole thing is the distance, yeah, distance to get first can see. Yeah, so this is how far you can see, and this is your altitude. I mean, that's the altitude. Okay, correct. So it says how many miles of this can see given the plane is going 70,000. So 7 miles is the altitude. 7. And what did you put there? I wonder where you got the 7,000 miles. So that's true. Okay, yeah, well, there you go. As soon as you put in 17,000, done.
No.
No, right now? Okay. All right, let's take a look at the next couple. Jackie, which one did you do? This one right here? That one over here? Okay, great. So folks, Jackie did this one. It's a really nice solution. She had the negative square root of 25 over 28. We're going to ignore the negative for a while. She broke the root into the root of the numerator, root of the denominator. She simplified the numerator, and then she also simplified the denominator. Root 28 is really root 4 times root 7. Now right there, you went ahead and multiplied top and bottom by root 7, but not root 4. Right, because root 4 is really 2. Yeah, so you just got rid of the root 7 by multiplying the top and bottom. So then you, on the top, had 5 times root 7, and on the bottom, you just remembered and did all at once in your head that root 7 times root 7 is 7, and root 4 is 2, so 2 times 7 is 14? Yeah, very good. Now, if you wanted to, you could have immediately put a 2 there. And that would be fine, because that way you wouldn't have had to do that in your head later on. But however, yeah, totally works. And she even put the negative sign in at the end. So that's it. Really nice. And who did the next one? This one? Was that Jasmine?
So,
Oh, number 15. Okay, so who did that one? Jasmine. Oh yeah, that's right, Jasmine left. Okay, but she has a really nice solution here. In order to rationalize a denominator that is a binomial, you have to multiply by the conjugate. And the conjugate means same numbers but different sign. So she multiplied by the conjugate. On the bottom, the middle terms canceled out, and she got 59. And on the top, she just distributed the 5, and she got 40 plus 5 root 5 over 59. Is that right? Is that what everyone else got? All right, really nice solution. And so that was Jasmine. So Kai, is this you, Kai? All right. Well, that's okay. So Kai had root 4x minus 3 equals 0. And so she had to isolate the root, so she moved the 3 over. And then once the root was isolated, squared both sides. And that got 4x minus 3 equals 9. Added the 3 over, divided by 4, and you got 3. Yeah, really nice solution. All of these are great solutions, folks. So who's next then? That brings us to the next two people, which is Amber and Deegan. Deegan, why do you get stars next to your name?
Oh, just that guy over there put a star on my name.
Yeah, that guy, he's a big joker, isn't he? Calling people Manny, putting stars on the board. All right, go for it, guys. Back to the beginning, huh? Do I have a stapler? Yeah, I have a couple. Some in my office, some at home. I might even have one in my car. No. Oh, I'm sorry. I thought you were just asking if I had a stapler.
No, I don't think that.
Actually, there is one. Would you know it? There's a stapler right here. Hey, guys. Now, see, I'm a joker, too. All right, Emily, did you have a question? All right, go ahead.
Why does this turn to a 11? So it's just 7?
Yeah, take a look. What's a root times a root? A root times a root is a root. And what is the square root of 49?
49. Oh, okay, that's what.
Now, another way to look at it is that root 7 is being multiplied by itself. So that means root 7 is being squared. And what happens to the square root? That's two different ways to know that the root 7 times root 7 is 7. So I wonder what another way is. How else could we prove to ourselves that root 7 times root 7 is equal to 7? Okay. So, there's 3 ways to know, but what's a 4th? I have no idea. I'm just messing. I don't know. I mean, there probably is another way to say it. I just don't know what that would be. That'd be a fun idea. You're saying root 7 times root 7. What does that do? Gee, I don't know. I wonder how to divide both sides by root 7. I'm just being silly. Trying to figure it out. So I'm saying something divided by root 7 is root 7. I don't know. No. I'm just messing around. Anyway, that's 3 ways to know.
Okay.
Does that answer your question?
Yeah.
Try it. Just start now. What if I come back in 5 minutes? Hey, did you just dye your hair purple? That's it, man. I haven't noticed. I'm sorry, but it looks good. It's very subtle. Wow, fantastic. Eduardo? Okay. That's Daniel. No? Hi. Let's see what I gotta say, I'm having a hard time walking. Yes, it's tough. I mean, this is tough. So what do we have? We have 5, 4, 7. So let's start. What we really have 5 over root 4. That's what we're doing. Right? Yeah, that's what we're doing. So if you want to do some subtraction like somewhere else, root 4 simplifies. That's what we're doing. I would say we want to rationalize the we multiply by whatever the root is in the denominator. So what's the numerator? Oh, Yeah, it's 507. Now, what's the denominator? You can only multiply both times wholes. So there's no other whole number more. And you can multiply roots by roots. So what's root 7 times root 7? What is that? You already know that. Oh, but yeah, I mean, that's it. What was your question?
Oh, no, I was just trying to figure it out. That's all.
Oh, okay. Well, yeah, so root 7 times root 7 is 7. But why is that? Because root 7 times root 7 is root multiplied by square root 40 times 7. So then it's like 7. And so now it's 7. Yeah, so as much as possible, if you can break it down, one step at a time. There you go.
Also,
Oh, yeah. So what you're telling me is that the solution is correct. Is it no? All right. Then. Yeah. Well, I want to see that you verify it. So doing your head isn't quite enough. I want to see. Now you can make it short as you like, right? Already put it 6 and 6. And then you can go straight to the answer, the square root of 9. Yeah. This right here would be the full You could even have left out that. Had you written down root 6 plus 3, 6 minus 3, I believe that everyone would be 6 plus 3 minus 6 minus 3. So that would be. But I would say two lines. One line tells you what number you're typing, and the second line tells you what number it is. So really a 2-line check is probably the number. Plugging in the number, just showing you 16. But yeah, this is good to see because it washes out. Yeah, it comes down to that. Hello? Okay. Video. Oh, yeah, I'm sure a lot of people do it because they're going to put that. That's not so much. So if they do, it's not very often. Oh, that's so important. Sweet, right? So you're telling me that you're named Gloria and your name is Julia and you can't see more than in the head? Are you having like this? You gotta find another name that ends in X. Are you still in Well, you can find a boyfriend that ends in X. Yeah, exactly. She's got it. Yeah, oh, yeah. Well, I don't know if you guys know my name. And I'm talking about that would be the tops. Yeah. Okay. Wait a minute. Wait, so how do you jump that up? Remember to the side square. And then it was. Yeah, that's it. Ever got a question? All right, okay, thank you. Let them go. We're gonna try something. Oh yeah, you were rationalizing the denominator. Did it work? Oh yeah, there it is. So you multiply by that on top, 40 plus 5. You did the FOIL on the bottom, so 64 plus and minus. How was that? Well, you got it. And you did it by multiplying the conjugate of Oh, well, now you get to do one on your own. We're going to do eight. That's challenge. Martha, another question? The practice test with all the solutions? No, I wasn't going to. I mean, this is what we're doing right now. Yeah, I mean, this is the practice test. So we're doing it on the board right now, and you're copying everything down. So it's like it's posted online. Because you've just done it all.
What do
Done?
you want us to answer for number one? What do you want us to write?
Honestly, I just want to see the graph. I want
So
to.
as long as we're doing that, that's.
Yeah,
and
yeah,
if we're
yeah.
showing that.
I believe what I wrote was make a table of values with at least 4 coordinates and then graph it.
Okay.
Yeah, so you definitely.
Okay, so you have that.
Yeah. The
So
table of
you have
values.
to-
And then,
Okay.
yeah, this is part of the answer, and then that is part of the answer. Yep, very nice. Okay, I think more people came up here. Amber, where's your solution? Okay, folks, let's take a look at Amber's solution. Amber had a root minus a root equals 0. Now, is that even possible that this root could subtract that root and it would equal 0? I mean, I think it's possible. This is a positive number, correct? Because a root is always positive. And then you're subtracting another positive number. So that is possible. You could have something minus something equaling 0. What must be the case if something minus something equals 0? What do you know about those two things? If something minus something is 0, what do you know about those two things? They're equal to each other, which of course is what we find out a minute later when we move that term to the right. We say they're equal to each other, right? So that root really is equal to that root. And we moved it over so that you could square both sides and cancel the root. So Amber canceled the roots, and then she just did a normal algebra problem where she moved her variables to the left, moved the numbers to the right, and she got 15/7. So that works. Great solution, full credit. Okay, who did Deegan? Where's yours? All right. So Deegan, he had, again, a square root equaling p plus 2. And is that possible? Could a square root, which is always positive, be equal to p plus 2? Yeah, I mean, provided p is such that p plus 2 is a positive number. So this could work. So Deegan squared both sides, and then he has a quadratic. He FOILed that, and then he canceled his p squared terms. And then he started the process of moving all of his variables to the right and his numbers to the left, and he got p equals 5. Did you all get p equals 5? Yeah. Yeah, another great solution. We didn't check this answer, did we? Did anyone plug 15/7 into that mess? Were you motivated to plug 15/7 into that mess? I mean, I know Jesus did it, because one of his favorite activities is checking his solutions by plugging it back into the original. He was telling me about it the other day. Now, isn't it easy, though, to plug it into your calculator? It is easy to plug it into your calculator, because in your calculator, you could go ahead and just do, here, I'm going to type it out for you so you can see it. Root, and it'd be 9 parentheses 15 divided by 7 parentheses minus 7. And then end the root, start a new root, 2 times 15 divided by 7 plus 8. And when you hit enter, it should equal 0. Anyway, that's not terrible. You could easily plug that into your calculator. I know that we sometimes think, oh, I don't want to plug a fraction into anything. But that's if you were doing it by hand. That would be a real pain. But if you're just plugging that into your calculator, it's no big deal. You just wrap parentheses around it and put a divide by sign. It's easy. You can definitely plug that into your calculator and check your answer. Same thing goes for 5. Did 5 work, Deegan? It did? Does 5 work, folks? If you plug it in, I mean, we all agree it's 5 because the answer in the back says it's 5, right? But what if you didn't have the answer key? How would you know? You'd have to plug it in. Yeah, you'd have to plug it in. So then we would have the square root of 25 minus 25 plus 49. So that's the square root of 49, which is 7. So 7. And then 5 plus 2 is 7. And there we go, 7 equals 7. So it's a true statement and it works. All right, well, thank you, Deegan. Nice solution. And here's our last, well, almost our last two. Do you all have these two problems?
Yeah.
You do?
No.
Emily, which one are you doing? Is that root x plus 3?
Yeah.
Oh, I didn't give you the other one, huh? Okay, well, that's fine. So come on up, Emily and Kim. Kim, you're doing the t one, t equals 2 pi?
Yeah.
Okay. All right, come on up.
Yeah.
Well, let's see, where was I? I think I just talked with Martha. Don't
No,
press it.
you did.
Oh, you
You
did?
answered mine, yeah.
Oh.
Thanks.
Come on. Eduardo. No. Okay, thanks. Great.
So how do I know
I'll tell you. First, yeah, you should write it. When you're dealing with a root in an equation, that's only the positive. If you're doing algebra, like say that you're doing x squared plus 7 equals. Now in algebra, whenever you do a square root, it's plus or minus. Okay, so that's one definition. If you're doing algebra, and so notice, this is an equation, and now that is an action step. Okay, so equation, action step. Now here's a new equation. That's an equation. So my action step is root. When the square root is an action step, that's when it's plus or minus. So now at this point, it's x equals plus or minus for the special 36. So it's plus or minus 6. So it's plus or minus if it's an action step. But it's not plus or minus if you're solving an equation. So you notice that root is an equation one. Because action steps is different. You know what action steps are like. Like here, an action step would be adding 7 to both sides, subtracting 2 away from both sides, dividing 7 on both sides. Action steps are things that happen twice, in 2 places. This root is just part of the equation. It's not part of the action step. So therefore it's just plus. The other thing is like, now see like here, they're telling me what that they want the negative solution. So that wouldn't be a plus or minus, that would just be a minus. Here. If you're cube rooting with a negative number, it's negative. Yeah. And like here you're square rooting it, but they already told you they want the negative solution. Yep, so that would be the difference. Right. What other class are you studying right now? Really? What? And is it talking about economics? That's what you're reading about?
Yeah.
Oh, you have to read the article about it. Really? Is it history of it? Oh, all right. Jackie, you got a question? Gotta go for it. Well, no, I wouldn't do 9 and 8. 9 is not the biggest square number that goes in 72. Where's your square root number like? I mean your square number like. Because you want to find the biggest square number that goes in 72. What? That's an evil laugh. It is an evil laugh, to tell you the truth. I've just never thought to write all that down before. All right, folks, here we have our last couple of problems. Who was, oh, I didn't even erase the names. Who was that, Emily?
No.
This was Emily, and who's the other one? Oh yeah, Kim, and you're right there. Okay, so I think it goes Emily, then Kim. So here we go. Emily. Emily got to solve this one. So the roots were already isolated. She squared both sides. That means she got to FOIL that. She had a quadratic. She moved her terms over to the right, so she had a quadratic equaling 0. That allowed her to factor and then use the zero product rule to say 6 and 1 were both solutions. So first of all, very nice algebra. That looks great. And then she went ahead and checked 6 and 1. So she plugged in the 6, and that got a true statement. She plugged in the 1, and that got a false statement. Why is this one false? Right, I mean, obviously 2 is not equal to -2, but why did she say the answer was 2? Why didn't she just go ahead and say the answer was -2? Because the square root is plus or minus, so why didn't she just put down the -1? Because then it would have been true, right? So why didn't she put the square root to be the -2? Or better yet, why didn't she put plus or minus 2?
Didn't you say you can't do that in a equation?
Right, because in an equation, the root is only asking for the positive root. So that's why the square root of 4 is 2, because we're only looking for the positive root. Likewise, the square root of 9 is positive 3, that's positive 2. So when the root is in an equation, it's only asking for the positive root. Okay, very nice. Who's that, Emily? Very nice solution. And she wrote extraneous, very good. Have any of you started using extraneous in your real life? Maybe within the next couple of weeks before the semester's over, you'll just start slipping it in there in conversations. Maybe. All right, and then Kim had this last one, which she was trying to solve for L. So notice what she did, folks. You'd say L is being divided by K, square rooted, and multiplied by 2 pi. So she started by dividing off the 2 pi. And then she said L is being divided by K and square rooted, so she squared both sides. And then L was being divided by K, so she multiplied by K on both sides. And that's the solution. So that looks really good. All right. Well, folks, I've made it around the room, I think, 3 times now. That was really nice to get to talk with each of you and answer your questions. I hope you found that helpful. What I'd like to do now is finish the last 2 problems from the packet, because we didn't. We were on this page, the very last page, and I think we did 86 and 87, but we did not do 88 and 89. So, the last 2 problems are actually really fun word problems because they represent something real. Those are real equations that model actual reality, which is always fun. So let's take a look at the first one, 88. The distance d in miles that can be seen from the surface of the ocean is given by d equals 1.6 root h. Folks, what does that even mean? The distance that can be seen from the surface of the ocean. What are they asking? So for instance, here you are, you're submerged up to your neck, and you're swimming, and you're shouting for help. Woo! Or perhaps you're having a nice time because you want to be swimming in that gigantic, scary ocean. I just find it a little scary to be in the middle of the ocean because you have no idea what's underneath you. So the question is, how far away can you see? Yeah, barely. I mean, it depends on how rough the water is. I mean, if the water is going up and down, how far away can you see? I mean, just probably from like here to the wall or from here to the next wave, you can barely see it all. Well, let's just say that it's a flat, clear ocean and that you're in a little rowboat dinghy, and so you're able to actually sit up and be like at least a couple feet off the ground. Now I'm happy because sharks won't eat me as quickly. So how far away can you see if you're just floating on the clear ocean, no waves? Just take a guess. How far do you think you can see? Your guess is 1.6 miles? I mean, that's not a bad guess, because really they're saying the distance d in miles. So everyone diagram this. This is miles. The distance in d miles that can be seen on the surface of the ocean is given by d equals 1.6 root h, where h is the height in feet above the surface. So h is the height in feet above the surface. So feet above. So if I'm in a little rowboat, how high up can I see? Well, I don't know. Let's go back to the example where I'm in the water. How high above the water are my eyeballs if I'm swimming? Here I am. I'm up to my neck in water. How far above the surface of the water is my eyeballs? Would anyone like to estimate how big that is in feet? Sounds like 1 foot would be a good estimate. My eyeballs would be about 1 foot above the water. So Deegan's answer, if you plug in 1, how far away can I see? If I plug in a 1 right there, 1.6 times root 1 is 1.6. So you can see 1.6 miles. So if you're stranded in the middle of the ocean and you're just sitting there treading water, you can only see a little more than 1.5 miles in all directions. So what are the odds of seeing a boat? I mean, pretty slim. What'd you say, Daniel? Yeah, very slim. I mean, you can only see a circle of 1.6 miles in all directions. So the chance of there being a boat there, when in fact the ocean is like super gigantically bigger than that, like as big as this building, if not more, the chances of you seeing any boats in there are really slim. The chances of you seeing a shark fin in there are pretty good. Because you'll be able to see that one coming for you. All right, so what is this question actually asking then? How high would a platform have to be to see 20.5 miles? So what are they saying that the 20.5 miles is? Are they saying that's your height above, or are they saying that's how far you can see? Yeah, that's how far you can see. So you would plug in the 20.5 equals 1.6 h, root h, and then you solve for h. So again, they're telling you they want you to be able to see 20.5 miles. So how many feet above the surface would you have to be? Anyone want to take a guess how high up off the ground you'd have to be in order to see 20 miles? They're really high. How far can you see in Phoenix? Like if you just go out here and look out the window, how far away do you think you can see? 20 miles maybe? Maybe. I don't think that far because all we can really see is the mountains that are closest to us, and that cuts off our vision of anything that's beyond it. But let's say there were no mountains. Maybe. Yeah. Okay, well, folks, how do we solve it? H is being square rooted and multiplied by 1.6. You divide by 1.6. And then you get root h is equal to something. Then how do you solve for h? Square root both sides? Square both sides. So 20.5 divided by 1.6, which is 12.8125. So then you square both sides because that cancels the root. And so h is equal to 164.16 feet above the ground. How tall is that? 164 feet above the ground. It's a little taller than me. Right? How tall? How tall is one floor of a building? This is a very tall ceiling. How tall normally is it one floor of a building? Is it 10 feet? I actually have no idea what the standard is. I also want to say 10, Matthew. Let's find out. How tall is the average floor of a building? How tall is a floor of a building? Oh, there we go. Generally, this is around 10 feet. Super. So how many stories of a building is that? A 16-story building. Geez, do we have any 16-story buildings nearby? I mean, there's a hotel across the street, but wait. This hotel across the street, is that 16 stories tall? I bet it is. I bet that. So do you guys all know that hotel right across the street? I don't know the name of it. But yeah, pretty tall. So if we were standing on top of that building, how far away could you see? The 20 miles. Yeah. So that's what that formula says. Okay, how about the next one? The time t in seconds for a pendulum of length L to make one swing is given by that. Now this is fascinating. They're actually telling us the truth about reality on planet Earth. They're saying that the time it takes for a pendulum of length L to swing is given by t equals 2 pi root L over 38. And they're saying how long is a pendulum if it makes a swing in 1.4 seconds? Everyone, just for fun, can we change the problem and say 1 second? No? Okay, we'll do the problem that it is. So where do we put the 1.4 seconds? Yeah, for time. And we want to go backwards and solve for L. Now, folks, I think I would do this whole problem on your, I would have your calculator out and do every step on your calculator while you do it. So for instance, I'm going to divide both sides by 2 pi. And I would like to automatically write down the answer. So 1.4 divided by parenthesis 2 pi. I'd be willing to bet that some of you might accidentally write 1.4 divided by 2 pi, and that will give you the wrong answer. It has to be 2 pi in parentheses to tell your calculator that you're dividing by both 2 and pi. Yeah? What? What about what? Did you change your mind? Okay. All right, so that's 0.2228169 equals root L over 38. And then what do we have to do? Square both sides, so I'm immediately going to do it on my calculator. I'm squaring both sides. Yeah, it's really good to have your calculator on you. That way, as you're doing the algebra, you are typing it down on your paper as well. Now I multiply both sides by 38. And again, I did it on my calculator times 38. And so it's 1.8 8, 6. So what does that mean? How long is 1.886? Oh, is that in feet? Yeah, it's length in feet. So that's not bad. 1.8 feet, I mean, that's almost 2 feet. So that's it. If I had a pendulum that was this long, can you all see the pendulum? They're saying that it would take 1.4 seconds to swing out and back. So that was 1.4 seconds. And that was 1.4 seconds. Okay, I have a couple bonus questions for you then. On planet Earth, because that's what this formula is talking about, how long of a piece of string would you need for it to swing back and forth in 1 second? Gosh, I sure hope this is the formula for the planet Earth. What if it's not the formula for planet Earth? This doesn't look like the formula for planet Earth. I think it's supposed to be L over 10. I think they just plugged in some random number. How do I check? How do we check, folks? We ask our friend Google. Formula for time of period of pendulum. Aha, there's the formula. It's 2 pi square root L over G, where G represents the gravity of the planet that you happen to be on. And the gravity of the planet that we happen to be on. But it's supposed to be in meters, too. Oh, that's why it's 38, because they're doing it in feet instead of meters. Could that be? What is gravity constant on Earth in feet? They normally, well, it's not pretty much. Oh, on Earth it's 32.174. That's the number we should be using. Okay, standard gravity, there we go. The standard gravity, acceleration due to gravity is 32.17. So everybody, let's do this problem. We're going to use the correct value, 32.17. And we're going to answer the real question, how long does it take for how long would a pendulum have to be to swing back and forth once? So that's the question right there. They're saying, how long would the pendulum have to be so that it swings back and forth once in 1 second? So again, you would take out your calculator, you do the whole thing on your calculator. So I would take my 1 and then divide it by 2 pi.
That's 0.159 equals the root of L over 32.17.
Then you square both sides.
0.02533 equals L over 32.17.
Then you multiply times 32.17. And the answer turns out to be 0.814 feet. So a little less than a foot, they're saying. If you have a pendulum that's a little less than a foot, and you let it go, it should 1 second. 1 second. 1 second. That'd be worth trying later today. You know, tear your shoelace out of your shoe. Don't really do that, that's so inconvenient. But find some sort of a string and just see if you make it a little less than a foot. That is 0.8 of a foot. How many inches is that? 9.77 inches. So if you cut off a piece of string and you put a bob at the end, you let it swing, it should swing exactly 1 second. And you could use that pendulum to keep time. All right, well, folks, what questions do you have? We're all done with the practice tests. I have some bonus questions for you up here. And you all can take your guesses, or you can just think about it. But my challenge for you is to find when is the square root of a number equal to itself? Don't shout out the answer yet. This is my challenge question for you. When is the square root of a number equal to itself? I claim at least 2 numbers have this property. When is the square of a number equal to itself? I claim at least 2 numbers have this property. Yeah. When can you add a number to itself and it will equal itself? I claim at least 1 number has that property. When can you take a number, subtract it from itself, and you get that number back again? There's at least 1 number that's true. And then when can you multiply a number times itself and it will equal itself? But isn't that the same as the problem already up here? Yeah, so that's a duplicate problem. And finally, when can you take a number, divide it by itself, and it will equal itself? So does anybody have any of these answers?
Yes.
Which one do you want to shout out? Deegan? What's the last one?
Is it? You said two.
I think this is,
Two grand.
well, no, I think there's just one answer. I think this one, there's just one. Yeah, 1. So that would be the case if x equals 1, whatever 1 equals 1. Is there any other number in the universe where that's true?
Yeah.
Well, is 0 divided by 0 equals 0? Is that? That's undefined. You can't divide by 0. Yeah. Okay, so that's one of the solutions. Any others, folks? Do you want to try one out?
Yeah.
Well, hold on, Deegan, you already got to do one. Yeah, Kim?
0 plus 0.
Yeah, exactly. That's only going to work if it's 0 plus 0 equals 0. But how do you know there's not any others? How could we find out if there were any others? You could do algebra. What's x plus x? And let's move the x over to this side. So minus the x, that gives us now 1x equals 0. How do you solve for x? Divide off the 1, and therefore x equals 0. And so that's the only solution. That's it. There's just one solution there. So this solution was definitely 0. This solution was definitely 1. How could we have solved this one? Well, x over x is 1. And so immediately the answer is 1. What about this one, anybody? When is something minus itself equal to itself? Also 0. Yep, that's just 0. And again, could we have solved that? X minus x is 0. Again, the algebra presents the answer immediately. Okay, now how about these two? Yep, 1 is one of them. The square root of 1 is equal to 1. And 0, the square root of 0 is equal to 0. What about this one? Yeah, 1 works. 1 squared is 1. And 0. But how do you know there aren't any other answers? Maybe we just lucked out and guessed. Because what, Jess? Right, because the exponents of 2, there's only 2 solutions. So we don't need to keep looking for more. Would negative 1 work? Right, but we're saying x squared is equal to x. And so that'd be negative 1 squared. Yeah, anyway, those are just a couple of fun problems that just occurred to me while I was walking around the room talking to all of you. Okay, well, we just have a little bit of time left. How about I give you back your quizzes? Liliet. Liliet. That's so funny. Name your daughter Juliet. Everyone, as I pass back your Everyone, as I pass back your quiz, I'll go ahead and tell all of you that number two on the quiz. When you get your quiz back, read those instructions very closely. Jasmine and this. Hi. Emily. Stephanie. Chris. Eduardo. Aria. Jackie. Right. All right, folks. Did anyone not get their? Everyone got a quiz? Give me a second, guys. I'll find it. Everybody else, I think we're done. I know that, well, it's 2:40. I don't have anything else for you. I'm not necessarily saying that you should leave. I'm just saying this is just time